Unless you have been living in a cave in the past 2 years, you have heard of AutoML. And depends on where you have heard it from, it can be the best thing ever happened to data science, the evil invention that will put thousands of data scientists out of their jobs, or anything in between. In this episode, we talk about the state-of-the-art AutoML, what is hype versus what is reality, how to think about it practically, and how you can get started with AutoML in your team. Hello, ladies and gentlemen. Welcome to another episode of Naked Data Science. This is Hao.
And I'm Nima.
I actually know this time what we are going to talk about, Nima. I think it's AutoML.
Yeah, we want to talk about automation in data science, the most popular manifestation of which is AutoML or automated machine learning.
I think I first hear people in our team talking about this a while back, but then recently, especially in the past, I would say 6 to 9 months, I start seeing a lot of business type of articles start mentioning this. But then it's also in very typical new technology fashion. It's kind of half fiction, half truth. And I actually don't know which half is fiction, which half is truth. So then I'm quite happy we're going to talk about it today. So I can show fully my ignorance on the topic. But then hopefully at the end of the episode, we can help our audience get a better grasp of it to think about it more realistically and drop the fiction part.
Yeah, hopefully. You're right. More recently, it's gaining a lot more momentum and it's appearing a lot more in popular forums and news and other places where you read about data science. The basic idea is not really that new. I think at least since 2013, there were works that were focusing on automating different parts of machine learning. The name says it, but then it's good to give a brief description of it. Basically, the idea is to automate what traditionally humans do in a data science pipeline or in a machine learning pipeline. Most of the historical focus has been on machine learning, so not necessarily every aspect of data science, but actually the more recent developments are covering more and more holistically set of tasks that you're facing when you're doing data-driven problem solving or data science.
This is what I also read in those business-oriented sources. But then I think devils are in details, right? So in those articles I read, this part about things humans used to do, depends on which article you read, it can be interpreted as everything data scientists used to do with regard to machine learning nowadays can be handled by AutoML. I just don't think that is true.
I think it has huge propensity and potential for being hyped. You can imagine how much hype was there around traditional neural networks and calling them deep networks. And then suddenly deep AI came to the picture. And now the story of AutoML can be hyped in degrees that is kind of unimaginable. So basically you can have deep networks making deep networks. And I think this is the ultimate story of making hype. You can have machines that make machine learning, if you want to look at it that way. But in practical terms, it's a very natural flow of things in many ways. I can imagine most data scientists who've worked on multiple projects came to realize after a while that these are the things I keep doing, that I keep repeating time and time again in my projects. And at least a subset of those data scientists have started to automate part of this process. This has happened to me, and I'm sure happened to many other data scientists. But do you realize this is the steps I'm always doing, for instance, in feature engineering or in model selection or in other parts of the process where you're working with data. And after a while, when you work on multiple projects, when you work with multiple data sets, you come to realize that this can be abstracted, this can be generalized. You can write pieces of code that automate things that you do yourself kind of manually when you're working on the projects. The idea of AutoML in practice is also very similar to this. It's this natural flow of things that after enough problems have been solved, after we've seen enough examples, we can generalize from them and we can write pieces of code that do part of this process. That to me is the real sense of what AutoML is offering. I have to say, this is also a very high level look at things. And there are, in practice, many interesting, novel and exciting scientific, theoretical, and specifically machine-related challenges inside there, which are still in rather early stages and hold huge potential for improving things.
if you look at history, because history always repeats itself, right? So whenever there is significantly new technology, some kind of disruptive technology, it always started from more pure technical, if there's such a thing, perspective. For example, when machine learning and data science first become popular again, early 2010s, then you really start seeing that a lot of the focus back then is how to get things to work technically. But then over time, more and more these things are being abstracted in packages or libraries. A lot of things are being automated. So then if you look at nowadays how you do data science and machine learning, and you compare to where the effort was put on mostly 10 years ago, it's very, very different, right? Back then, a lot of the lower level stuff, and nowadays a lot more the higher abstraction level. And this is a trend you tend to see in all kind of new technologies. And from business perspective, a lot of this is driven by the economy. As long as it is more efficient or effective to do so, to abstract more things away, then there is always a need and tendency to do so. By effective, what I meant is that if there is strong incentive that by abstracting some things away can make creation of software cheaper or creating a solution cheaper while still keeping the same or even slightly worse quality or functionality, that is still okay, because from economy perspective, you still got much higher return on investment. I think that's a trend that we tend to see. But then from what I understand of what you just said is that it's not all the human work that we can automate away at this point, that not all work done by data scientists nowadays can be or will be replaced by AutoML. Is that a correct understanding?
Definitely considering the current level of service and effectiveness that existing AutoML tools provide, you cannot do safely without having a data scientist. And that might not be even the final goal in a way. I can imagine AutoML can be packaged in those terms, but I don't think that will be the image in the future, to completely remove a data scientist from the picture, or completely removing a human from the picture becoming the ultimate goal in the end, in the whole process of problem solving. Maybe it's helpful to get a little bit more concrete idea of what current AutoML can provide. I think in a way you can consider it as a collection of different steps that we manage to develop in automating or actually making algorithmic a lot of the decisions that we have to make, and a lot of the steps that we typically take in working with data. For instance, there are good works on data pre-processing, on feature engineering. There are good works on feature selection for learning algorithms. And these are put together in an AutoML pipeline. Now combine this with algorithmic ways of model selection, hyperparameter optimization in machine learning, which are basically searches through space of possible solutions, possible parameters for your solutions to find the best ones. And now on top of it, also there are very good works in making machine learning interpretable and even describing things in languages which are understandable by humans. All of these put together can automate a lot of things that typically data scientists do. It doesn't mean also that data scientists always do these by hand. It's not like that all the feature engineering always done by hand. But I think what AutoML provides is packaging a lot of these best practices and going towards making pipelines that can automate these steps as much as possible, while also focusing on making this whole thing readable, accessible, and interpretable by humans who want to use this. This is very helpful. And I think, especially when you look inside it, and I would love to maybe touch upon a bit on some of the most beautiful technical challenges that are in there, if you have time during this podcast. When you look inside it, there are a lot of novel problems that are coming to the picture. And again, typically there are not problems that came to be yesterday. For instance, I had the chance, and I was lucky enough to just be a fly on the wall and see the people who were initiating this AutoML process. One of my previous colleagues was heavily working on a project that is called OpenML, which was one of the first steps into making machine learning datasets and practices and algorithms more uniformly available as a benchmark. And that is one of the sources that is empowering AutoML to a very large extent. But putting those beautiful problems aside, you still have to see the bigger picture that machine learning or whatever other data science set of steps and processes and pipelines are used to solve a problem in the world. And to solve problems effectively and to create value effectively, there's still a lot more needed than automated machine learning. I also admire that many pioneers, many thought leaders in the field of AutoML are also seeing this in the future. And even though they acknowledge it as a very far-fetched goal, this is still in the agenda to achieve maybe sometime in the future, to also be able to identify the greatest problems that are out there to solve and frame them in a way that can be solved. But currently, with the state of art in AutoML or machine learning, probably all the research around data science, we're still very far from leaving humans completely out of the loop in that manner. The way that I can see AutoML be very helpful is playing the role of a more effective tool, more reliable tool, more efficient tool to do part of the job in solving the right problem and in creating value in society and in business.
Just wearing my business hat on and trying to push the idea to the extreme. Does it mean, imagine if in my business we have a team of data scientists, if I go to them and say, hey guys, from tomorrow, I give you a month to learn AutoML and get very good at it. And then after that 1 month, is it realistic for me to expect that they can just be like twice more productive than they are before?
I'm actually unaware if that kind of measurement has been performed before. I know that there are studies that compare what can AutoML produce as an output, typically in terms of the criteria or KPI that the machine learning algorithm is optimizing for, versus what a machine learning expert or an experienced machine learner working with these models and making choices can produce. And there are various studies. Some of them claim that the automated machine learning can already outperform some of the experts. And there are also other studies on different benchmarks that show it's not the case that AutoML necessarily outperforms, for instance, even a very well-tuned random forest model. But they are getting close. In that sense, you can imagine part of the efficiency comes from humans making less decisions, doing less things manually in some sense. And what is typically automated in this manner is a lot of search. So a lot of search for finding better solutions. If you want to measure the efficiency gain like this, I think you need to also consider the trade-off in value and time. So for instance, I definitely expect that after getting familiar with these tools, just by the fact that you're automating more stuff, you save a bit of time. But at least based on practice or depending on the problem that you're solving, I think in most typical situations, the time gain is not going to be the biggest factor. And I don't expect your team to be able to solve 2 times the number of problems that we're able to solve before. But I think the path towards solving those problems would be smoother. And after getting at the results, probably you're more confident that the search space has been searched more thoroughly than it would have by humans. And that's actually one of the main benefits that AutoML algorithms provide. It's that they are systemizing this search through different alternatives. And maybe that's also one of the biggest contributions of AutoML to the machine learning community. Not just automation, not just more efficiency, but actually forcing the community to go towards higher systemization of the process that we typically apply in finding machine learning models. One of the places that this comes more pronounced is in deep networks, of course, because something that is less talked about deep networks is that you have to decide on an architecture for your network. And this search for an architecture can itself be considered quite an expert task in a way, a task that needs you to have worked with multiple problems before and have a good sense of what can create value and what cannot create value. And for instance, this is one of the bigger parts in, if not all, in most of the AutoML packages out there, this search for finding a better network architecture. And the sense that AutoML can be helpful here is systemizing this search, automating this search, and then informing the data scientists about the best options that the algorithm could find in this search space, for instance.
So then what you're saying is that the main benefit for the business at this point of time is not so much on the efficiency gain, but rather allowing the business to get more confidence about how optimal a solution is once we reach a solution.
I like to just make it clear there that I'm not saying that it's not going to make things more efficient. I just don't have a good estimation, and I haven't seen the studies that show how much more efficient things will become.
I think that's fair. But even taking that part aside, I still think that, at least in our experience, we have seen several times that our team work on a solution, we think we reach a good point, and then we revisit it after 6 months, and then we found out that, wow, actually we were not at an optimal point, and then we could have gone further. And from business perspective, these are practically missed opportunity in a certain way. And given how things are moving and also how short the window of opportunities are nowadays, I think being able to get to a higher confidence about, we explore this direction and we are quite confident we got to a pretty optimal solution, I think that is super powerful for the business, especially in today's market.
Yeah, absolutely. Of course, AutoML is not delivering magic. So for instance, if you don't have enough data to come to the optimal solution, AutoML is not going to help there. But in terms of getting more confidence in having done some sort of systematic search through the space of solutions, I think AutoML can definitely give you more confidence, make life easier on data scientists as well as people who want to use those models. But you have to be careful what you expect from it, what kind of gains you expect from it. For instance, it might be that with the work of one of your data scientists, you get to, let's say, a 90% accuracy. And by using AutoML, I don't want to put a number on it, but then it is likely that you get a number which is a slightly higher or lower than that. In terms of business value, that doesn't necessarily mean you're gonna change the business value hugely. But then, of course, it has other gains in the way of working and in certainty and confidence in the solutions that you find in this manner.
Imagine you have some less experienced data scientists in your team. So, for example, a junior data scientist. Would you say that as a team lead, you would also have more confidence in the work, the delivery of that person, if that person has followed through a more systematic process, for example, using AutoML, than if that person just do it a more traditional way?
I'm not certain, to be honest, how to think about it. Of course, we don't have the experience of doing a lot of projects with AutoML. So maybe after a while, I can have a better idea here. But I think it's kind of a double-edged sword. Like many other things, it has its pros and cons. On one hand, it's safe to leave a lot of things in the hands of a well-performing automated solution, which can search through the solution space in a systematic way. But on the other hand, you also have the effect of dealing with more and more of a black box. So more things are going to be abstracted away. And whether you get better or worse value in this way depends also on the opacity and the interpretability of what the system does. For instance, some of the commercial systems out there currently do not provide the best interpretability. They don't even reveal a lot of the times. I can imagine probably by design and for some other reasons, they don't reveal even what are the best algorithms that they found or how do they compare to the other ones, because probably they want to abstract away all the complexity into I found a solution for you. And a lot of solutions are going more and more towards another hype, which is the no-code machine learning hype. So in those situations, I think to be able to rely on the work and to be able to be on top of the work that you're delivering, it might be beneficial to let a junior work with simpler models instead of this very powerful tool that can do a lot of things that might not be easily accessible and transparent to the person who's using them. Probably even a combination of doing one solution on your own and then comparing it to what AutoML can provide could be helpful. It's also good to consider that the whole AutoML ecosystem, the whole umbrella term, does not need to necessarily contain a pipeline that you cannot control. Although some of the most common commercial products are framed in that way, you can also use pieces of AutoML. So for instance, you can use libraries that do feature engineering and feature selection for you. A lot of times these come also with better interpretation, with better explanation about what they are doing. In that sense, then I think it might be better to equip a more junior person with these pieces and get clarity on the use of those pieces instead of necessarily this huge beast of pipelines and parts that solve a problem once altogether and spit out the output.
I think what you see in software engineering is something similar, which is once you start using a lot of the existing frameworks and libraries that have already abstracted so many things away, then if this is what somebody who's new to the craft only have worked with, then it's very likely that person got into a situation that person is quite good with working with these tools specifically, but then when something unexpected happen or when they need to switch in a situation that they cannot use this tool anymore, they kind of got lost because they don't necessarily pick up the more fundamental layer behind it. Would you say so?
Yeah, I think that's a very good insight to have. In a lot of fields, as we go along, we put more things inside black boxes and we take them off the shelf and use them. Depending on the level of advancement of knowledge and the level of stability of the found solutions, you need to know more or less about what's happening inside these black boxes, especially for people who are more junior, who are still developing, who are still gaining the knowledge. I think it's important to keep an eye on knowing the fundamentals, on being able to tell a story at least of what is happening inside that black box. Because like any other automation, you lose some flexibility when you automate. And it's important to be able to crack into that box if needed, to know what is happening inside the box. What are the pitfalls, peculiarities of the tools and systems that are inside the boxes? It's kind of a fine line to thread. I can imagine, of course, as time goes on, more and more things will become off the shelf, readily available. You and I are old enough to remember the times when, even sometimes for implementing something like a decision tree, you had to code a lot of stuff. If you wanted to make good visualization, you had to code a lot of stuff. And those days are past. A lot of those requirements have now become kind of atomic commands that you can run. They have been standardized to a very good degree that you can get almost everything that you need out of those tools. In the same sense, I think AutoML needs to go through those generations of evolution to find out what is that right level of flexibility versus automation that lets most people in most situations solve their problems. And I think it's not quite there yet. And rightfully, it needs more time to get to that stage and get to that level. And until then, it's really important to know what's happening inside these boxes and to be able to step inside or at least replicate some of what's happening in some way to be able to actually find effective solutions to the problems we're facing.
Yeah, I think if you decided to use this tool in your team or business, then developing that intuition, the correct intuition, not just by playing with the tool itself, but then, like Nima said, really look inside the black box and try to replicate some of the stuff, that can be very helpful. You mentioned that there are some technical topics that you want to go into, and I'm also curious as well.
Yeah, there are a lot of very exciting stuff happening in the AutoML, in research, in industry, which are these days kind of nicely mixed because there's so much motivation to do machine learning and machine learning products in the industry. One of the most exciting ones to me is the idea of meta learning. So basically, if you consider people who've done a lot of machine learning, they typically talk about them gaining some kind of expertise. They can look at a new problem, analyze a new problem, and based on the experience that they have, they know this kind of method is more suitable here. Or maybe even this kind of hyperparameter selection, this kind of structure for the network or for a graphical model is more suitable for the problem you're facing. And the idea of meta learning, which is also a big part of AutoML, is that you can learn this using a machine. So basically, imagine that you have done 100 machine learning projects. You can somehow describe these projects by some kind of attributes. And on each of these projects, you might have also tried, let's say, 1 to 5 different machine learning methods with their parameters. So now you have a data set which tells you, given these properties of the problem, these properties of the solution, this was the outcome. Naturally, you have now data to also do machine learning. You can now apply machine learning on a history of projects that involve machine learning. And I think it's a very beautiful idea, not just because it's recursive, but because it's kind of a missing part that you expect there to be in a logical sense in the history of machine learning. There have been so many projects, there have been so many competitions, so many public projects, private projects, and people have tried out many different solutions on these. It's logical to expect that maybe after a while we can learn what kind of solutions would be suitable for what kind of problems. And this is the idea behind meta learning, which is one of the approaches that can be helpful in doing a more effective search through the solution space. There are, of course, a lot of other very beautiful ideas. So, for instance, the same kind of thinking can be applied to feature engineering. There have been projects before, starting with some kind of raw data. And in these projects, people have tried different methods for feature engineering and feature selection. Now we also have the result of these kind of feature engineering and feature selection. So now you can see we have another probably very large data set that can be used to learn what kind of feature engineering techniques can be helpful on what kind of problems or what kind of data. To me, that is one of the most elegant ideas around machine learning and one of the most exciting research topics in AutoML that can be pursued. And AutoML is full of these kind of examples.
Let's imagine, okay, I have a business. We started doing some data science, machine learning stuff, but then I want to go to market much faster with these kind of solutions. And we haven't done 100 projects yet. Is there a way to speed up the process? I mean, can I somehow get the meta learning from projects other people have done? How generalizable are these things?
You can definitely avoid the cold start to a large extent. So that's why, for instance, the OpenML project is very exciting, because that was the main goal of that project, which started, I think, more than 10 years ago, to collect, first of all the data sets that are typically used in machine learning projects. Of course, starting with academic publications and research papers, and then to also apply, even beyond what was applied in the original research paper, different benchmarks of algorithms on these problems. So that makes the data set that we talked about. And of course, going a step further is to try to actually make models or make explanations about what kind of algorithms, what kind of methods work on what kind of problems. And these days, in some of the AutoML libraries and packages out there, this kind of meta learning is already built in. AutoScikit-learn is the one that I can remember definitely has some kind of meta learning built in. It's more like a warm start rather than a cold start situation. But this is a direction which I think will be expanded much more as we go into the future, and also following the trend of sharing more and more of these kind of experiments and this kind of data. We can give a big shout out to people who worked on OpenML and had this vision more than 10 years ago.
That was amazing.
Yeah, I think this is one of the most exciting parts about this as well. And that's why I think, like, the history of places where automation has been done is typically assumed that what happens to the humans now if we automate things. And we shouldn't forget that people still have to build AutoML models. If you actually peek a bit into the field, you realize that there are huge number of research questions and research directions to move into the future. So there definitely is going to be enough work for data scientists to work on. And I can also imagine that no matter how good AutoML becomes, as long as there is motivation to improve and to make it better, there's going to be enough work for data scientists to be busy with.
Okay, so nobody need to be afraid that they're going to lose their job anytime soon. That was really interesting. So is there any other technical topics that can be interesting to our audience?
There are definitely a lot of cool technical topics inside AutoML, but another one that caught my attention a lot is the explainability and interpretability. For instance, one of the projects that falls also inside the AutoML universe in a way is automatic statistician. And one of the features that is really pronounced there is readability and interpretability of what this automated machine is doing. It starts by considering a language of existing models that can be composed by a different kind of combination together. The reason for this partly is making something that is explainable from the beginning. So if you have as your goal from the get-go that I'm not going to only fit models to this data, but I'm going to fit models that can be explained to humans based on this data, you're exploring a very interesting direction. And in general, one of the more interesting topics that I see very pronounced already in the AutoML community is this focus on transparency and explainability of what is happening inside the black box. And like I said, in the automatic statistician case, it's even kind of one of the building principles of the automatic solution. I think that's definitely one of the other very cool stuff happening in AutoML. And it's really exciting to see what happens with this direction in the future. If you check that project, for instance, there's a very famous example of analyzing a time series. You can already see that in the output, the model is described or summarized typically by a few bullet points, which are readable by any business person who can have some insight into the domain that they are facing. For me, this is definitely one of the more exciting directions, and I'm really looking forward to see what kind of other developments will come up in this direction.
Wow, I'm going to check that out. So we talk about the hype versus non-hype part of it. We talk about some interesting details. What would your advice be to an average data scientist or a average data science team lead on this topic? Should they start trying it? Is there some part of their skill set or competencies they should emphasize a bit more, knowing that AutoML will be more and more mainstream in the future?
I can definitely recommend to data scientists and team leads to try it out and see what the state of art is at currently. It's a very fast moving field, so I can imagine in a short time we might see also again very big improvements in the field. So it's definitely a moving target, but it's already worth trying it out. And in trying it out, beside, of course, getting a sense of what it can offer, I think it would be really beneficial if in your evaluation, you can decide on KPIs that are important for you, beside the fact that this is a really cool machine learning project. See what kind of KPIs for your team, for the projects you're working, could be potentially improved by using this tool, and do a fair evaluation of how much improvement, if any, is achieved by the current state of art that these tools can provide. That's something that I haven't done systematically at all. For instance, the question that you mentioned about the time being saved, I think that's definitely a very interesting one. And I wonder, in different teams with different level of expertise that people have, what kind of time savings can be achieved by using these solutions. Of course, a part of the outcome is also the confidence and certainty that you might get in the automatic solution having searched for you automatically through this space of possible solutions. And this search is, again, one of those probably more interesting technical topics, because it's typically not a brute force search. It's a search that is trying to be intelligent based on different optimization criteria. So once you enter this, probably you're also gonna face technical topics that you didn't know before. It's a good chance to get familiar with them. It also could be an effective trap to go into many rabbit holes. So definitely be careful if you step in there. There are a lot of exciting topics there, and you need to have decided how deep you want to go there and what you want to get out of it. The final thing, which I think is very important, is don't forget there's no free lunch. Basically, what AutoML does is a lot of search. And that means trying out a lot of solutions. Although people are working to make this search more and more intelligent, in principle, it means this automated solution is gonna exhaust a lot of resources. It's going to try out a lot of paths. And that's how you can also get the confidence and certainty that the search space has been really looked into. In practical terms, I think if you want to do a fair evaluation of what AutoML can provide, measure the time saving, measure the potential save in model performance, but put it beside the cost that you're paying for this. In my very limited experience of trying out AutoML, I quickly ran into resource issues and I quickly sensed how much money you might have to pay for this. For instance, if you use some of the most popular commercial services out there, you need to be careful about the cost that you might be incurring by using this.
Are we talking about the more like of 50%, 100% more? Or are we more talk about at the range of like 5, 10, 20 times more?
It definitely depends how many options and how much resources do you exhaust manually versus the number that is tried out by the automated solution. But I can imagine it could be, for instance, 10 times more. Consider it this way. You can try out X solutions yourself manually, and now you're using an automated solutions. How many more alternatives do you expect it to search for you? In most realistic scenarios, this number could easily be tens or even hundreds compared to what you do manually. That's where you need to be careful. Again, it's a very fast moving object. So even the costs are probably subject to change in the future. And you might also be able to run everything on your laptop if you can wait long enough and you can fit enough things on your own laptop. But giving the practical picture of most things happening in cloud infrastructures that we are paying for in one way or another, just be careful. And even in your trials, I think it would be very beneficial to make some kind of cost estimation compared to your typical traditional, if you want to call them manual solutions.
Yeah, if your cloud infrastructure resource management is not in place, just be very careful when you try out this thing, okay?
And it's also such a big coincidence that most cloud providers are really following this AutoML path.
I can't imagine why. All right. I think we covered a lot about AutoML at this point because of the technology is fast moving, as you mentioned. So we'll probably come back to it and cover it in a later episode as well. It's almost like product reviews. 6 months down the line, this is our long-term review of things. I think that can be interesting to do. What do you think?
I think it's nice if we come back and revisit this subject in a while.
And tradition of the show, one key takeaway for our audience, but you also mentioned that you would recommend data scientists and data science team leads to try it out themselves. Although you mentioned that the field is still quite fast moving at this moment and resources and good information can be all over the place and therefore it's easy for people to fall into a rabbit hole at a certain point. What do you think if we create a collection of the key resources that you came across, key pieces of knowledge you came across, and share that with our audience at a certain point?
I think that's a good idea.
I think if we do that, then if they want to explore themselves, they certainly can. But if they are limited on time, we can maybe help them to save a couple of hours here and there.
Yeah, absolutely. There are already good resources out there, but also, like you said, the information can be scattered. So it would be nice if we make our own naked data science introduction to the topic.
Okay, so for our listeners, if you want to receive the all mysterious and comprehensive and ultimate naked data science guide to AutoML, just go to our website, nds.show. Leave your email address there, and we will send the guide to you once it is available. All right, thank you for listening to another episode of Naked Data Science. See you next time.